Binary and Logistic Regression by Kelso Kwan, Mitch Borgert, John Morgan, Lindsay McPhillips, and Martin Eong. What is logistic regression? Logistic regression is a model where there is only one or more independent variables with an outcome of only two levels. The graphs are generally sigmoid functions or S-curves. The variables. There's one binary dependent variable, which is generally coded as 0 or 1. And examples for this are pass-fail, win-lose, alive-dead, healthy-sick, and pregnant-not. Some useful functions here that we'll get into later are the logit of p, which can be put as the natural log of p divided by 1 over p, where p is within 0 and 1, or as logit of p as b0 plus b1 x1 all the way until bk xk. Pros. First, logistic regression does not require a linear relationship between the dependent and independent variables. Second, the error terms, residuals, do not need to be normally distributed. Third, homoscedasticity is not required. Finally, the dependent variable in logistic regression is not measured on an interval or ratio scale. The assumptions needed. First, binary logistic regression requires the dependent variable to be binary, and ordinal logistic regression requires the dependent variable to be ordinal. Second, logistic regression requires the observations to be independent of each other. In other words, the observations should not come from repeated measurements or matched data. Third, logistic regression requires there to be little or no multi-collinearity among the independent variables. This means that the independent variables should not be too highly correlated with each other. Fourth, logistic regression assumes linearity of independent variables and log odds. Although this analysis does not require the dependent and independent variables to be related linearly, it requires that the independent variables are linearly related to the log odds. Finally, logistic regression typically requires a large sample size. A general guideline is that you need at minimum of 10 cases with the least frequent outcome for each independent variable in your model. For example, if you have 5 independent variables and the expected probability of your least frequent outcome is 10%, then you need a minimum sample size of 500 multiplied by 10 times 5 divided by 0.1.